Hello and welcome to another episode of Shop Happenings. Today we're going to take a look at this project, and it's composed of a whole bunch of pieces and parts and bits. I'm going to kind of go over what we did here. This was a really neat project for us. We partnered up with two other schools in the country. We partnered up with Burton Center for the Arts and Technology in Roanoke, Virginia. We also partnered up with Steamwood High School in Steamwood, Illinois. The gentleman in Roanoke, Virginia is making parts that are separate from what we made for this piece, which I'll go over in a minute. His name's Sean Burns. His students are working on that. And Mr. Matt Urbach made this part with his students, and he also made this. This was a late entry. This was supposed to be done by another school. That gentleman got very busy and couldn't help, so the three of us kind of came up with this idea. And what this is a vise to go on a mini mill, and this plate is made to be an adapter plate so we can take this vise off any machine and bolt it onto another machine by putting different holes in this. So this is a blank right now. It's not made for a machine specifically, but what it will be, it'll be made for a specific machine by machining additional holes in this. So Sean Burns and Matt Urbach and myself and all of our students communicated back and forth with designs and ideas. We started out with some rough ideas, so here's one of our ideas that we came up with, and you can see all the scribbles and all the marks from our design and trying to process out what we did. Once we determined that we could get a design for this part right here, and that's what this print is all about, with all these notes and sketches on it, we then 3D printed a piece to see if our design would work and see if it even looked right, and it did. 3D print, our 3D printer isn't as accurate as what that piece of paper would allow us to do, and it's not as accurate as what we can machine. So after 3D printing, we did a whole bunch more math and a bunch of drawings to solidify what our profile would look like, or the end, and we needed to determine like where to put holes and where to do our offsets and how to do our math, and we did that mathematically, and then we backed it up here with CAD. So it was pretty cool to develop this along the process. In the midst of developing this, we were in constant contact with Mr. Burns and Mr. Urbach's students, and we had to communicate back and forth because this part was being made as we were designing this. So it's kind of like real-world manufacturing, which is really cool across the state. The next thing we had to design was this part, and as you can see, we 3D printed that as well. This is all our scribbles and designs trying to figure out how do we get this, how do we machine it, what's our geometry look like. And we were actually able to machine one of these in aluminum. We ended up not using this design because we found it too complicated. Not only that we had to machine all the weird angles, but we also had to we had to drill some blind holes in each end to allow for the clamping mechanism to clamp into the bottom of the jaw here, or the bottom of the vise. So we changed direction big time, and unfortunately I don't have that student's drawings, but he made this. And this was our simpler, more elegant design than this. This was really complicated for us, and we had to press fit some pins, and we were just concerned this was going to fall apart. So we went with this design, just a simple cylinder. We turned this down, and again, I forget diameters, I don't have the prints here. And then we drilled a hole that's dead center, 1/4 thread. We did these bosses, but we weren't sure what the gap was supposed to be in this adapter plate, so we left stock on here so that when these got shipped to the other schools, they were able to turn these down and face those off so it works. And what was neat about this project by collaborating is our students did all the collaboration. They were the ones that emailed back and forth, talked to each other via email, and what a great project to have students work on, because it's more like global manufacturing that we see today. The vise is really simple to use. This goes down here like this, so it just sits in its little grooves. We then put our moving vise jaw in here. We have our little adapter, and this was the last part we designed. This was actually the simplest of the three. This was done in no time at all. As you can see, here's this print. There's only one note that this student made, and you see his RPM calculation up here, which is kind of nice. But he had some very small calculations. Really simple part for us to design. Here it is. Works really, it's elegantly simple. That part then will be threaded, or the bolt, sorry. The cap screw just slides into there. It sits nice and flat on his little recess there. Oops. And this threads into that cylinder at the bottom. Just got to get it lined up right. I'm always amazed when I do stuff like this on camera that it never works as good as it did when I practiced. So you're seeing me fumble a little bit here. You have to apologize for that. There we go. So that'll thread in, and that allows that vise to be locked down. So this works really good. Notice I haven't just finger tighted it and finger tight that. Notice it doesn't wiggle, it doesn't jiggle, and it holds that very simply. Notice that hangs down. That was part of our design because it required the base plate here, and that base plate allows that to sit on there really nice. And then we just use some socket head cap screws and we attach this vise to the base plate. And like I said before, this base plate will be custom machined for whoever is going to use it on their mini mill so that it can be indexed quickly. So this vise will be attached to this permanently, and then the plate can be moved from mill to mill with different mounting holes. We don't have one of those little mini mills. The other two schools do. They're going to be using these, so we just wanted to help out. And what a great collaborative project here to do with students. I don't think our students understand the gravity of what they did by working across states, not even face to face with anybody, and designing things and shooting ideas back and forth via email. It was really, really elaborate, I thought, and it was a really cool project. This project was funded in part by the Harbor Freight Tools for Schools program. Both Matt, Sean, and myself have all been recipients of one of their grants in their program. I cannot speak highly enough of Harbor Freight Tools for Schools. Thank you so much for introducing the three of us and allowing us to do a project like this and funding this. It was just absolutely incredible, and it was so enjoyable to do. Thank you, Matt and Sean. I hope you get a chance to watch this video, and I hope I did it justice for all the work that the three of us have done and our students have done. It's just amazing to be able to jump out of our comfort zone and get out of our classrooms and work with other students from other districts. It's just so rewarding. So I hope you enjoyed this video, and I hope you enjoyed this little project we did. I'm really pleased with how it came out. It's just so elegant, and it's so just wonderful and amazing, and the tolerances are so good. I'm so happy. As always, thanks for watching, and I hope you stay tuned for more.